Hey class, starting a new chapter. This chapter is chapter 14, section 1. We're talking about just the general idea of sequences and series. Section 2 is specifically arithmetic, but for now it's just what are sequences and series. And I can tell you very simply that a sequence is a list of numbers that more or less follow a pattern separated by commas. 1, 2, 3, 4. 2, 4, 6, 8. A series is when we take that list of numbers, that sequence, and change the commas out for plus signs. So we're adding them all together. And to simplify some of those things, we end up with this summation notation. So I'm going to go through, I'm going to trust that the first half of the homework you did okay with, or you emailed me as you had issues. But let's move into the second half where we have some of this summation stuff. And when it says expand, it actually wants you to create those different sequences, that different sequence, and then make sure you put plus signs between them, and then figure it out. So what might this look like? Well, this summation notation means starting with k, and this k can be any, usually it's I, J, K, sometimes N. Desmos uses N that you'll see. But this right here is your general term, and we want terms with k equals 3, 4, and 5. I stop at 5 because that's what the notation tells me to do. So I actually only have 3 terms. The terms numbered 3, 4, and 5. So because I'm expanding, I want to actually determine what those are. So I want to have k and 2k minus 3. K needs to be 3, 4, and 5. So 2 to the 3 minus 3, 2 to the 4 minus 3, 2 to the 5 minus 3. And if I evaluate each of those, then I have my expansion. 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32. Subtracting, we get 5, 13, and 29. So my expansion is 5 plus 13 plus 29. And I believe when you add those together, you end up getting 47. Right? So that's how the whole idea of this notation and expansion works. All right? Let's do another one. Kind of a strange one. We've got from 1 to 5 of our rule that is 4. I'm actually going to leave this one up here. This right here I think was k equals 3 to 5 of 2 to the k minus 3. And it equaled that right there. So I'm going to show that in Desmos. What about this? This is I, and this is 4. So when I equals 1, 2, 3, 4, 5, stop. And now my rule says 4. Does it say to do anything concerning I? No, it just says 4. So just 4, 4, 4, 4, 4. Kind of lame. We end up getting 4 plus 4 plus 4 plus 4 plus 4. 5 4s makes 20. Our answer ends up being 20. So that's how a very simple rule could end up looking. All right. So now let's go to the next one. What about this? This is a puzzle-like where we're actually seeing the expansion and trying to work backwards to come up with the summation notation. All right. So it tells us what to use as our lower limit and what letter to use. So I know that I've got this right here. My summation from I equals 1 to something. And I need to figure out what the rule is. So now let's take a look at our pattern. 1 squared plus 2 squared plus 3 squared. Well, it seems pretty straightforward that the square stays the same throughout. And this ends up going up by 1. So this must be my I squared. Now, when do I stop? I have 1 squared, 2 squared, 3, well, it looks like I stop at 9. So this ends up being my answer for this one. Does it ask me to evaluate it? No, it doesn't. Could I? Yes, I could, and I'm not going to. All right, so that's how that works. I think I've got another one that might be a little bit more difficult. Yeah, take a look at this one. What's going on here? Well, I know that I've got my summation from I equals 1, but I need to know when I'm stopping. Now it looks like I've got a 1 in a numerator every time, and it looks like I'm squaring things. This looks like 2 squared, 2 cubed. Oh, look, 2n minus 1. So this could be a 1, 2 to the 1. This could be 2 squared, 2 cubed. Maybe this would be 2 to the 0. Remember how 2 to the 0 is 1? So this looks like 2. Oh, okay, look. It tells you right there even. 2 to the n minus 1. Oh, not n. I minus 1. Now, when do I stop? When do I stop putting numbers in? Well, apparently I stop when I get to n. So whatever n happens to be, that would be my answer there. So that's the process. Now let me show you how some of this works on Desmos. Remember this example here? End slideshow. All right, this right here. Remember how we had, let me show you how to do it before you see that it works. Let me show you how you get there. Usually when you open up a Desmos screen, you graph stuff. Well, if you open up the keyboard and go over here to Functions, and go over up here to Miscellaneous, you can see the summation right there. Click that in, and then you use n instead of whatever k or I. Just make sure you have n. But we had k equals 3. I'm going to have n equals 3. We had it stop at 5. We're going to have a stop at 5 here. And our rule is 2 to the k minus 3. Always use parentheses. 2 raised to the, not k, but n. Arrow out of that, do a minus 3. And there we see our answer as 47, just like we got right there. Now it doesn't expand it for us, but it will show us that pretty well. Okay, that's it. That's quite a lot of stuff. There's a lot of stuff in this section. Feel free, please continue. Email me with questions, and then I'll see you back at 14.2.